Hello people, I'm Bharat Acharya. Welcome to a new video. So in today's video, I'm going to introduce this subject to you called Computer Organization and Architecture. We also call it COA, or in short CO. So many students learn it. Do you have an idea who all learns this subject? Most of the branches of engineering, whether BE or if you're doing BTech or ME, MTech, all BSc students or MSc students, people who are preparing for GATE exam, that's the maximum number of people who learn this subject because it carries so much weightage in the exam. So now when you want to learn this subject, you pick up the regular books and you see it's very intimidating because they're all very good books, okay? Hayes, William Stallings, Tannenbaum, etc. They're excellent books on the subject. Even I've learned from those books, but they're very verbose because that's the nature of the subject. There's so much to explain, so the text just keeps going on and on and on and on. There are thousands of pages. So students just get lost in that whole space and invariably end up paying attention on things which actually are the least important in the big scope of understanding the subject. So this video is here to give you a guide as to what is there in the subject, what are the things that you should be learning, and how this subject changes you from a layman who knows little bit about how a computer works, which even school kids do, to a computer professional. By the time you finish learning this subject, you know what you're talking. If you're playing a video, or if you're watching a video like this, or if you are on Instagram, or if you are whatever you do on your phone or your computer, you will know exactly what's going on. How does the information come from the internet? Where does it get stored? Where is it temporarily held? Who processes it? How does it get displayed? What are the things that make all of this faster? How can you improve it further? And so on. Okay, a clear formal study of a computer, not a layman's point of view, which everybody has anyway. Okay, so that's what this subject is all about. Now let's start. Tell me, what's the basic function of a computer? Which computer am I talking about? Maybe the computer which is there inside this silly remote control, or maybe the one which is there inside your phone, or maybe the one that you're using in your home computer. What's their function? What do they all do? The main job of a computer is to execute programs. Are you listening? From now till the last word spoken by me in this whole subject, not in this video. I'm going to make 40 videos of this subject. They'll all be there on my website, 𝗏𝗏𝐴𝐴𝑑ucation.com. Till the last word I speak on this subject, the whole and sole purpose is to execute programs. Are you clear? That's what a computer does. Whether you're on Facebook or on Instagram or on Snapchat or on YouTube or playing a game, whatever you're doing, it's a program. Okay? So we are learning how programs execute, how can we make them better. That's the whole idea. Now, we said the job of a computer is to execute programs. Who executes programs? The whole computer? Is your whole phone executing a program? No. The programs are executed by the heart of your computer, that's your processor. That big smile on my face is because I also teach this subject. In case you've learned it from me or by yourself, the various processors, 𝗕𝗵, 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 etc. That's the heart of your computer. Okay, one misunderstanding students have. They think they know processors, so they know this subject. Oh no, not at all. Not at all. I'll make 40 videos on this subject. I've made 40 videos on each of these processors. Compare the videos. They have nothing in common. Yes, the ground is the same. We are learning a computer. But what you learn when you learn 𝗕𝗵 as a microprocessor subject and what you learn in computer organization is completely different. Okay, they have nothing to do with each other. Just knowing 𝗕𝗵 will give you a better sense of familiarity. You know the background, but that's it. Nothing more than that. So coming back, all programs are executed here. This is the brain of your computer which does all the work. Okay, but they are not stored here. How can programs be stored inside the processor? You have so many programs, you have so many apps in your phone, you have so many movies stored in your computer. How can they all be stored inside the processor? They are stored inside memory. Now again, when you say memory, it's not just one device. There are so many devices in memory. Hard disk, floppy, CD, DVD, pen drives, RAM, ROM, different types of RAMs, different types of ROMs, cache memory, L1, L2, L3 cache, etc. So memory itself is huge. A layman says information is stored in the memory. A COA student knows exactly at what time which information is stored in which memory. That's the difference. Okay, so so you'll be learning the memory. Memory's job is to store information. I/O, the third and the last component of a computer, is used to give inputs into the computer and produce outputs. I/O devices, school kids know this: keyboard, mouse, printer, monitor. Keyboard and mouse are input devices, printer, monitor, output devices. Do they run our programs? No. Do they store our programs? No. Then why are they needed? Just to give inputs and produce outputs. That's it. Every device over here has a clear role in the computer. Give inputs, produce outputs, store information, do the action, do the processing. Are you clear? The thing that connects all of them, these are called buses. Now everything that you see on the board is there in your subject. Are we clear? Everything over here. Okay? So I'll tell you how this subject goes. If I had to learn this subject all over again, I would love to do it. What a journey. Sometimes the journey is better than the destination. If I had to learn this subject all over again, this is the approach which even I would use. Now I know it because I've been teaching the subject for so long. Start with the processor. Okay? In the processor, there are two parts. Okay? If you have a COA exam pretty soon, 4 days from now, 5 days from now, maybe tomorrow, maybe a month later, and you want to pace out your whole preparation, this is the approach you should be taking to understand the subject the best and the easiest way. In the processor, there are two sections, the control unit and the execution unit. Both of them are very independent when you want to study. You may start with any one of the two, it doesn't matter. This is the more fun part. This is the more intense part. So I like to start from here because these are numbers. This shows you how we learn to add, subtract, multiply, divide. Now come on, since childhood, whenever you look at a calculator, it's human tendency. If you have a calculator in front of you, you'll enter one number, multiply, enter second number, equal to. There's some sadistic pleasure we get in doing that, but we do it. We have a natural inclination to learn or to perform add, subtract, multiply, divide. It just happens. So here, this is where we start the subject from. Okay? In this comes your ALU. Have you heard of ALU? Arithmetic Logic Unit. That's where all the action takes place. It has arithmetic and logic circuits. Okay? So when you're learning the execution unit, the ALU, the first thing I'm going to teach you is how to store numbers. You will not believe it, there are so many students who fail at this point. The first step of the subject itself they take is wrong. I ask them, how do you write 5? How is 5 written in binary? They say this is 5. My dear friend, take this as in 5. They take this as 5, put it in Booth's algorithm, run the algorithm 100 times, you will not get the correct answer. 5 into 3, you will not get 15. You will get something else altogether because this is not 5. This would have been 5 if it was an unsigned number. In signed system, things change. So, and all these algorithms that you learn are for signed numbers. So first thing before you learn how to multiply numbers and divide numbers is first you need to know how to store a number. How does a number even look like when you store it inside a computer? So that's what we're going to start with. Once we know how to store numbers, how numbers look like, then we go into adder circuits and we spend good time in understanding how two numbers, let's say 4, 0, 1, 0, 0 and 2, 0, 0, 1, 0. This is 4 and 2. I want to add them. That is 0, 1, 1, 0. This is 6. So how are two numbers added? What is the circuit that does this addition? Student says, sir, are you serious? You're going to teach me how to add two numbers? Who cares? Addition is such a basic thing. We keep reading question papers. We don't see addition anywhere. What comes is multiplication and division. Yes, I agree. Are you seeing the question paper now? I've been seeing it since 18 years. What happens is, once you understand how to add two numbers, listen to these words carefully. Once you understand how to add two numbers, you create that circuit using AND gates and OR gates. We'll be learning that. You have got your core building block. You've got your DNA of arithmetic and logic operations. I'm not exaggerating when I'm saying it. Your whole physical self is basically a reflection of your DNA. All arithmetic inside a computer is performed using that adder circuit. If you know that adder circuit, you don't know what you know. You still don't. I'm going to tell you now. That same adder circuit with a little bit of manipulation becomes a subtractor circuit. There is no circuit in the world that does subtraction. Okay? Okay? Subtraction is done by adding 2's complement, which means you need to do addition, which means it's the same adder circuit. Are you with me so far? So once you reach the level where you can add and subtract, you get on to learning multiplication algorithms. You learn one algorithm, then you learn the next, then you learn Booth's algorithm, the best one. When you finish learning Booth's algorithm, you realize, oh my God, in the whole algorithm, we never multiply. Though it's called Booth's algorithm for multiplication, you're doing 5 into 7, you get the answer 35, but hello, in the whole process, multiplication is never performed. What is performed is addition and subtraction. I repeat, addition and subtraction. Okay, it's not just addition, it's addition and subtraction. But anyway, so What did you understand? The same circuit that you made for doing add subtract can also do multiplication by just wiring it with a correct algorithm. By just programming it to work in a particular algorithm, that same circuit will give you the result of multiplication. Are you listening? Then when you learn division, same story. The whole process, restoring division, non-restoring division is what you learn. The faster one is non-restoring, the more accurate one for sign numbers is restoring. Anyway, I'll be teaching you that. When you learn that, you understand in the whole process you never divide. It's just addition and subtractions again, which means it's the same circuit. Then you learn floating point numbers, which have sign, exponent, mantissa, which I'll be teaching you why they are like that. Not just that what are they, why are they like that. Then you learn their floating point addition algorithm, subtraction algorithm, multiplication algorithm. Again you understand the whole process. The only thing you're doing is add and subtract, which means again the same circuit. So what am I saying? What is x raised to y? X into x into x into x into x, correct? What is x into x? So a set of repeated addition and subtraction, which means x raised to y is again done by the same circuit. Tan is done by the same circuit. Square root, cube root, anything is done by the same circuit. So that same cute adder, which is formed by 3 AND gates, an OR gate and 2 OR gates and etc. Just a handful of AND gate and OR gate, does all the arithmetic inside a computer. So starting with adder, you move on to subtraction, multiplication, division, and working with floating point numbers. That is your execution unit. Once you're done with that, this section is closed. Now you know how processing takes place. Now we go to the next step. Instructions. The control unit's job is to fetch, decode instructions. I repeat, what? Fetch and decode instructions. Look here. I said the job of a computer is to execute programs. What is a program? A set of instructions. Where are those instructions stored? In the memory. Who is going to execute them? The processor. How? Every instruction first of all will be fetched into the processor. Are you listening? Will be fetched into the processor. How? Using these buses. So that is fetches. A program is a set of instruction. Every instruction first of all has to be fetched. Once it is fetched, it has to be decoded. What is decoding? Converting the instruction into binary form is decoding. Rubbish. Typical Viva question, typical Viva answer, typical marks. Decoding does not mean converting an instruction into zeros and ones. It is already in zeros and ones. That's the opcode. So you would say, hello, sir, we never enter zeros and ones. Of course, you never enter. Which idiot is going to enter zeros and ones? That is machine language. That is automatically converted into zeros and ones. You enter C, C++, Java, VB, Oracle. That's higher level language. Then you give your program to a compiler. You know you compile your programs. Why do you compile your programs? To check for errors. Please don't give that stupid answer. You compile a program to convert it into machine language, binary language. You see after compilation there is a .bin file or .obj file formed. That is machine language. Similarly, you may type a program in assembly language, which is add B, C or add BL, If you learn microprocessors, that's the language you know. Then you give your program to an assembler, which converts into machine language. Moral of the story, when the program is stored in the memory, it is already in machine language. Are you listening? When the processor fetches the instruction, it already has got machine language. Decoding doesn't mean converting into machine language, it's already in machine language. Decoding means understanding that binary pattern. What does this binary format signify? 0010 add, 1010 subtract, 0011 multiply, 1011 divide, etc. Every instruction will have a particular binary pattern. That pattern is called opcode. I'll be showing you how the opcode is formed, etc., how the opcode gets decoded. So when the processor fetches an instruction, what it gets is an opcode. Then it analyzes that opcode. That is called decoding. By that it understands whether it has to add, subtract, multiply, divide, or etc., whatever it has to do. So the part of the processor that does this much, what? Fetching and decoding. Fetching and decoding is the control unit. The part that does execution is the execution unit. Execution unit has the ALU, which we already discussed. The control unit, when you learn, that's a separate chapter by itself. What does it teach you? First, it teaches you how instructions are formed, what is the format of an instruction, what is the addressing modes of instruction, how do you give your operands, what is pipelining, where you can make this process faster and faster and faster. I said it 3 times because the levels of pipelining keep changing and it's going on changing as I'm talking to you. Starting from a 2-stage pipeline, we reached a 20-stage pipeline. It's going to go much more than that. But anyway, so you learn pipelining and the benefits, the hazards of pipelining. Very typical exam question. Anyway, so then you learn how does the control unit decode the instruction. That's the most delicate part of this subject. When I teach that in my classroom lectures, All lectures are 3 hours in the classroom. That's the only lecture where I request the students to keep all their phones and all in a bag and keep all the bags aside. Because that is so delicate. It is wonderful, okay, but it's also very delicate. You're walking on thin ice when you're learning that, okay. One mistake and that's it. The whole concept comes down crashing. So that's where, but also it gives you that many marks. I tell the students when that lecture starts, give me 3 hours, I'll give you 20 marks. In Bombay University, that part alone comes for 20 marks. What does it include? Hardwired control units and microprogram control units. Okay, not soft-wired. These stupid local textbooks, local authors, they call this thing as soft-wired. There's nothing called soft-wired. How soft can a wire be? So it's called hardwired and microprogram control units. In hardwired, there's delay elements, state table method, sequence counter method, and in microprogram control unit there's Wilkie's design, there's typical microprogram control unit, there's single address field, dual address field, horizontal, vertical, nano programs, etc. Yeah, these words may be sounding very mind-blowing to you, but they're very simple when you actually understand it. It takes time to understand it, but once you understand it, they are very simple. What does it also do? It makes you understand how a computer works and helps you decide that tomorrow, if you want to do your PhD in computers, which part of it do you want to do it in? There's so much. Learning computers is such a vast field by itself. So it gives you a clear idea about each one of them. Then whichever takes your natural liking, where do you automatically get inclined towards, you pursue that in your further studies. Anyway, so that's your control unit. This whole part of learning the control unit and the execution unit forms your understanding of the processor. Okay. In terms of marks, 50%, 45 to 50% of your marks is just on this out of your whole subject. Okay, so it includes add, subtract, multiply, divide of the ALU and hardwired microprogram control unit and instructions and pipelining and micro instruction format and micro instruction sequencing, etc. of the control unit. All that part forms about 45 to 50%. Half of your paper is this. Then you get on to learning memory. When you learn memory, okay, each of them are independent topics. When you're learning the processor, your focus was fetch, decode and execute instructions. That is done. When you're learning memory, that part does not come across in your whole section of memory at all. Memory's job is to store. So your suo moto agenda is to understand how information is stored inside a computer, nothing more than that. Okay. Now when you say memory, there's so many devices, hard disk, floppy, CD, DVD, pen drives, they are called secondary memory. RAM and ROM are primary memory. Cache memory is an independent memory by itself which works as high speed memory. Then there are types of caches, L1, L2, L3, there is unified cache, there is split cache, look through cache, look aside cache, direct mapping, set associative mapping, etc. There's so much in memory alone. Okay, it's all very interesting. Virtual memory management teaches you segmentation, teaches you paging to make it very simple for you. Your book has chapters. In the chapters there are pages. In the pages there are paragraphs. In the paragraphs there is information. You want to access that information, that one single piece of information. Okay, but for that, how do you go about it? You tell your friend, I want so and so chapter, so and so. You don't tell the page number. Who remembers page numbers, everything? You say, I want so and so chapter, so and so topic inside the chapter, fourth line of that is where my answer is. Okay, this is called virtual address, also called logical address. Why? Because this is the logical way of remembering things. So and so chapter, so and so paragraph. Okay, or so and so subtopic. Game of Thrones, season 1, episode 10. 20th minute. We all know what happened at that time. So anyway, so that's the logical way of remembering it. Now when Game of Thrones as an example, using that as an example, okay, when that is stored inside your computer and you play it, it comes into your RAM, from the RAM it comes into your cache, from the cache it comes into L1 cache. Where did it come in the L1 cache is what you want to know. From where it was stored till where it finally is your conversion from logical address, virtual address, physical address, cache memory address. Okay, that's what is called address translation. That's what you learn in your book. Like I said, such chapters, there is something, and there is something inside a chapter subtopic, and there is a line of that subtopic that you want to learn. You bring that book to me. I remove the binding. I shuffle the book. Pick up 4 pages, keep it in my bag, pick up 1 page from the bag, take it over here. What do you want to know? First of all, whether my information has come here, and if it's come, where is it over here? That's what happens. Like I told you, is what happens inside a computer. Your file is there in your hard disk, then it gets broken down into pages, comes into your RAM, gets broken down into small sections, comes into your cache. From there it comes into the processor. So first of all is the ability to know whether it has come to the processor, and if it has come in that section, where is your information. So anyway, you'll be learning that. That's all address translation. It's very beautiful. The reason why I gave this introduction was to make you understand that it's completely different from what you're learning over here. There is a whole paradigm shift when you learn memory, which is so different from processor. So anyway, you learn all of that in the memory. You learn types of RAM, SRAM, DRAM. In SRAM, in DRAM there is SDRAM, there is RDRAM. In ROM there is ROM, PROM, EPROM, EEPROM, flash ROM. In hard disk you learn RAID level 0, 1, 2, 3, 4, 5, 6. You learn, there's so many things in memory. You can do a whole, it could be a whole subject by itself, but here it's a part of your subject, but still a big part. Out of, as a percentage, I said 45 to 50% was the processor, 30 to 35% of your marks are for memory. It is that big, okay? Lastly, and memory will have the maximum number of videos, though marks are more here, but these are smaller topics. Memory, each topic is a big topic, so will require more videos, and there are a lot of numericals that come in memory. So there will be, every topic will have a theory, then a numerical, then another video for theory, then another video for numerical. So it will be the biggest section of my video series. And lastly will come I/O. I/O is the simplest of all. In I/O you learn what is synchronous and asynchronous data transfer, what is serial and parallel data transfer, how are the bus structures like single bus, dual bus, multi-bus, closely coupled, loosely coupled systems. Then you learn I/O data transfer schemes. What are they? Processor controlled, where you learn memory mapped I/O and I/O mapped I/O. Interrupt driven I/O, where you learn the whole idea of interrupts, what are vectored, non-vectored, edge triggered, level triggered, high priority, low priority, etc. Interrupts, maskable, non-maskable and all. Then you learn DMA, direct memory access, transferring data directly between memory and I/O without involving the processor, so that the processor is free to do other operations, etc. And then finally you learn the most advanced form of I/O transfers, that's called I/O channels, also called I/O processor, where apart from main processor you just put another processor, like how graphics in your phone is controlled by another processor called GPU. Similarly, I/O transfers are controlled by another processor called I/O processor. With 8086 is the main processor, 8089 was the I/O processor. So you learn about that, and then you wrap up the subject by an answer called Flynn's classification, where you learn how multiple processors can be connected with each other, starting with SISD, then SIMD, then MISD, then MIMD. MIMD basically is your LAN network, where all computers have their own personal memory, personal I/O, everything together, independent, but it is connected to each other. Anyway, you'll understand it when you reach there. So that's it. That's what this whole subject is all about. As I said, every topic that I mentioned, there will be a video for it. So we did a rough layout. It always becomes more than what we make, but our rough layout itself had 40 videos. So in reality, it will end up being 55, 60 videos. We already started shooting the initial ones. The whole series I've promised myself to finish in the next 15 days. Hopefully by the end of April, all of it will be uploaded. The latest, as soon as we shoot, we're working, if I'm telling you we're working day and night on it, believe me, we are, okay? So as soon as it's all done, all of it will be uploaded and will be put up on my website. My website is called www.bharatacharyaeducation.com. You can watch the videos on the website, or you can watch it on my app with the same name, Bharat Acharya Education. It's an Android app, it's on the Google Play Store, and there's a subscription amount, but very low, everybody can put. I mean, the reason why there is an amount is because this cannot be free. There is so much work that we put in, it has to be viable for us. But I've kept the cost so low so that everybody can benefit from it, because I love this subject and I want more and more people to have the correct knowledge of this subject. India is becoming the software hub of the world. We are already in that drive. Let's push it ahead further. Okay, so that's my contribution to it. Now, wish you all the best. Do well. Hope to see you there.